Okay, everybody. Hi. Today we're going to talk about the differences in going from a 2D shape, 2D being a flat surface, which is what we've been working on so far, to going to a 3D shape. Now, you might remember that when we've been looking at things, perimeter is the outside of what we're looking at. Think of it like a picture frame. The perimeter is what creates the frame for a picture. If we're looking at area and volume, we're looking at the inside of something. So today, just to make a point, I thought it might be interesting to show you some of these cool science things you'll start to get to use 6th, 7th, 8th grade. This is what's called a graduated cylinder. And you can see I have red dye in there so far. There's 100 milliliters in there. This one has a total value of 100 milliliters. This one has a value of 200 milliliters. And this one has a total volume of 500 milliliters. Notice they're all different shapes. Tall and skinny, short and fat, but this one almost looks like a pyramid, right? So what happens, and what you can expect, is when I pour this in here, that if this is 100 milliliters, and this one can hold a total of 200, then this should be able to hold 2 of these. And when you look at it, you're like, wait a minute, this one's really tall. But it has to do with the volume, and we're going to figure out how to do volume of things today. Now, you can see, it shows me right here, 100 milliliter. This one holds a total of 500 milliliter, but this one does not have the markings on it. You just have to go with the fact that if it got up here to the very top, it would be 500. So, if I use this then, same 100 milliliters, and I pour it in here, wow, looks like there's hardly anything at all here. Well, that actually would be 1/5, because this being 100 and this being 500, we could make 5 of these fill one of those. So it has quite a bit of volume, right? But the whole big notion of all this is, how do you figure out volume? How do you figure out all this? You know, these are circles and triangles and pyramids, and you look at these things and go, wait a minute, I don't know where to start. Well, one of the things I thought would be helpful today would be, as we work in my workshop, to take a look here at a cardboard box. It's flat, right? But I want you to think of this as a perfect square. If I open it up and I fold it together, I now have a cube, or a perfect square. How many sides does a square have? Let's see what I did with my markers. Here we go. I'm going to start on this side. I have 1, 2, 3, 4, and I'm back to 1 again, right? So I've counted all those sides. I have a top, which would be 5, right there, and then I have a bottom, which would be 6. Now, if I wanted to figure out the size of a square, I would need to measure it. So I'm going to measure this for you. If I measure this, you're going to see that it is about 8.5 inches. And if I go across this way, it's also 8.5 inches. Now, so far, the only thing we've been doing to figure out area would be the flat side, or right here, the top side of the box. And we know that when we do the area of a square, what do we know about it? It is the base times the height. So we'd have 8.5 by 8.5. And that's how we're figuring out that area. If we're figuring out the perimeter, we have to go the whole way around all four sides. So we know how long each one of these sides have to be. And we know it's 8.5. So we would take 8.5 plus 8.5 plus 8.5 plus 8.5. And that would be our perimeter. Remember, the outside perimeter is like a picture frame. It's what's on the outside. The area is what's on the inside. So one of the ways we start to think about how we figure out volume is we have to figure out now not just one of these squares, but now, since our cube has 6 squares, we need to figure out the area of all 6. So that's what we're going to be working on. So with a square, it's pretty easy, right? Because the base and the height are the same length. But what if we did a different shape? Let me put that off to the side a second. For example, what if I have a box that is maybe long, but now it's thin? We would have to figure out, again, do we still have 6 sides? We do, and we can count them to be sure. 1, 2, 3, 4, 5, and 6. But what's going to be different about this one? Well, now you're going to see that we have different lengths. Let's see what happens, and let's measure this just for a second. If we measure the top of this box, and we go across for the base, we know our base is going to be about 13 inches. So what I'm going to do is write on the bottom here, base equals 13 inches. That also means that this side has to be the same, right? Now, what's the height of our box? Oh, it looks to me like it's about 10 inches. So I could say the height equals 10 inches. So, I want you to just take a minute and think about this. If we were going to figure out the area like we've done before, we have a formula. And what is it, everybody? It's the base times the height. So if it's the base times the height, what is the area of this top square? If you said 130 inches squared, you're right. Now, we're going to come back to that in a second, because one of the things you can notice that maybe, like with a square, you notice every single side is exactly the same, right? With a rectangle, it's a little bit different. With a rectangle, you notice this side is the same. Now, I also like to call one maybe the top and one the bottom, but now you have 2 of those. You have one here, but you also have one on the back. So you have 2 sides of a rectangle, the top and the bottom, that are going to be the same area. But then also, the same can be true for this side and this side. So if we measure, let's see how we do. Let's see. The base of that is about 13 and a half. Base equals 13, and I'm going to say 0.5, because it's easier to multiply that way, 0.5 inches. Now, we'll see. What would the height be? I measure the height here. It's about 3.5 inches. So, the height is 3.5 inches. Is this side the same as that side? The same length. Is this base the same as this? Yes, it is. So now, we'd have to figure figure out the area for this square. So it now becomes a new square, right? Here is a different side. So now this side has a different square. It's a rectangle rather. I'm saying square. It has a different panel. What's 3.5 times 13.5? Well, in my workshop, I have my phone, and in my phone, I have a calculator, and I take out my handy dandy calculator, and I say, what is 13.5 multiplied by 3.5? And it tells me 47.25. What? Inches squared, because we're figuring out the area. Now, just like we had two red sides, the top and the bottom, we have two purple sides. This is a purple side, and then the side directly behind it is also a purple side. So those two will have the same area. Now I'm coming to it, I promise. You'll understand this in a minute. But we still have two sides that are unaccounted for. So let's take a look at this puppy right here, and let's measure. And the base there is give me a different color. Alright, I'll use green. The base here equals 10 inches. So the base is 10 inches. Then we have to figure out the height. And the height in this case is about 3.5 inches. So the height equals 3.5. So now again, to figure out the inside here of the green, we take 3.5 and we multiply by 10. You can do that in your calculator, but I can tell you already, I know what it is because I can move my decimal point. We're going to do that in our next math. But if we take 10 times 3.5, that equals 35. And what is it? 35 inches squared. So when I look at my box a little bit more carefully here, I also see that I have a side over here, and that's also a green side. So with my rectangle, I'm going to realize something. I have two green sides, two red sides, and two purple sides. So when we start to figure out surface area, we're going to do base times height times length, but it will be a new equation.